We have been factoring trinomials when the coefficient of the x squared is 1. And before we get into factoring trinomials when we have a coefficient other than 1 of the x squared, we're going to talk about factoring by grouping. And it's exactly what it sounds like. You're going to group together terms in a polynomial and then factor the GCF, the greatest common factor, out of each of those terms. And then you're going to notice that you actually have another greatest common factor that you're going to be able to remove. So basically, after you group these terms together, you're going to factor out the GCF 3 different times. And so we're going to look at how that pattern plays out here in this first example.
Write the original polynomial. Factor out the GCF of each group of two terms. How should you group the terms of the polynomial? First, group the terms with the highest degrees. In this case, those are the terms of degree 3 and 2. If that doesn't work, try another grouping. Your goal is to find a common binomial factor.
Basically, you're trying to group these. In this example, we're grouping the first two together, and we'll group the last two together. But you're trying to group these so that you have a GCF to take out. Okay, if you were to group two things, for example, 3n to the third and 8, they have nothing in common. So it's going to make it a lot more difficult to actually factor if you don't have a GCF. So always group them so that you can factor something out.
Factor 3 times n squared from the first group, and factor 2 from the second group.
So notice the GCF of this one is 3 and n squared. So being able to take out that greatest common factor, 3n squared. So just divide everything by 3n squared. And then here, this one was a lot easier. The GCF of 2 and 8 is just 2. There's not an n in common because 8 doesn't have an n. So the only GCF there is the 2. So you divide everything by the greatest common factor.
Then factor out the common factor n minus 4. So the factors are 3 times n squared plus 2 and n minus 4.
Basically what you've got here is after you take out the 3n squared from the first two and you take out the 2 from the second two, you have binomials that are identical. You could think of this as one giant x and one giant x. And if I ask you what do these terms have in common, you would tell me the x. Well, in this case, it happens to be a binomial. So remove the entire binomial. This is the reason why when it showed the illustration, it took the two and merged them together into one. And a lot of people will write this out front, but this is the binomial they have in common. So pull that away from the two terms, and then what you have left over, the 3n squared plus 2, is your second parenthesis. So this is the hardest part of factoring by grouping. You just have to visualize that this entire parenthesis and this entire parenthesis, they are in common. Those are the greatest common factors of these two terms. So take it out. So literally just scratch this out and take it out and put it on the outside. And what you have left over is 3n squared plus 2. Now think about if you were to distribute. If you were to distribute n minus 4 to 3n squared, it would be 3n squared times n minus 4. Same thing here. If I were to distribute that entire parenthesis to the 2, I would have 2 times n minus 4. So it's just the distributive property backwards, taking out the greatest common factor. But that's your answer. That is the factored form of that cubic polynomial.
Check your factors by multiplying them together.
This is just basically FOIL method.
Since this matches the original polynomial, these factors are correct. it's your turn.
All right, so here is your cubic, because that's the highest degree, that's the degree of this polynomial. So cubic polynomial. Group them, and group them like you just did the last ones. Group the first two, so put parentheses around the first two, put parentheses around the second two, and take out the greatest common factor. Now, I'm not going to show you the answer choices just like I did on the trinomials because I want you to be able to factor this without working backwards from the multiple choice. Pause the video and take a moment to factor that. Now, your correct answer for the factored form of this polynomial is 2t squared plus 5 times quantity 4t plus 7. Now, you're going to have to factor out the GCF 3 different times, okay? The first time, once you group them, the first one was a 2t squared that I could take out of 8t cubed plus 14t squared, so that's 2t squared. Plus, and then out of this one, the only thing they had in common was a 5. So we're left with 4t plus 7. So both of these terms, even though these are really large, odd-looking monomials here, we can call them that terms, both of them have a 4t plus 7 in common. So we're going to take that 4t plus 7 out, and what's left over is the 2t squared plus 5. All right, let's look at another example.
In this problem, you will factor a polynomial completely. What is the factored form of 4 times q to the 4th power minus 10 times q to the 3rd power plus 16 times q squared minus 40 times q? Factor completely. Do the terms share any numerical or variable factors?
So this is always a good question to ask yourself, even when you're factoring just trinomials. Do you have any GCFs? Do you have any greatest common factors that I could take out first and make this problem much easier? So look at your 4 terms up there and think to yourself, do they have anything in common that I could factor out first and then start doing the rest of my factoring? Try to make it easy on yourself.
Yes. The terms have a common numerical factor of 2 and a common variable factor of q. The greatest common factor is 2 times q. First, factor out the greatest common factor. You can factor out 2 times q from each term.
All right, now notice they did this a little bit differently than we did, but basically they just divided every single one of these terms by 2q. And what was left over, what you've got in black here, that's what's going to be in your polynomial. We haven't ever written it out that way, but that's basically what they were doing, is just showing what each term will look like after you take away the 2q.
Now, factor the remaining polynomial by grouping. Group the terms with the highest degrees. Then, group the terms with the lowest degrees. Factor q squared from the first group, and factor 4 from the second group.
So exactly like what you did in the last example, you group the first two. Forget about this 2q for a little bit. You could just cover it up and don't think about it right now because we've already factored it out, so we don't need it anymore currently till the end. But you group the first two together and their GCF is q squared. They have no coefficients in common, so just a q squared. And then the last two, the only thing they have in common is a number 4. So factoring out the GCF from each one of those terms. And then look what you have. Look at your 2 binomials, exactly like the last problems. Our binomials are the same, so we're going to have to factor them out as well.
Now factor again to complete the factorization. So, the factored form of the polynomial is 2 times q times the quantity q squared plus 4 times the quantity 2 times q minus 5.
So basically all we did was, once you pull out this greatest common factor, you don't need it again until the very end, until you write your final solution. And then what was on the inside, we just factored by grouping. Grouped the first two together and factored out the GCF, then factored out that common binomial of 2q minus 5, and what we had left over was q squared plus 4.
Now it's your turn.
All right, so here's your polynomial, and I want you, again, this is just like the last example, so you're going to have a GCF. Always look for that first to make things easier, but you do have a greatest common factor here. So factor that out first, and then factor what you have left over by grouping, just like we have the other problems. All right, so your correct answer, pause the video if you still need more time, but your correct answer for this is 3h times the quantity h squared plus 2 times the quantity 2h plus 3. All right, so again, factor out your GCF, then factor by grouping. So you can look through there and see that's exactly what they did for this problem. And we will do more factoring by grouping together in class.